The mysteries of the cosmos have captivated humanity for centuries, and now, with the advent of cutting-edge technology, we are uncovering secrets that once seemed impossible to reach. One of the most incredible advancements in space exploration has been the launch of the James Webb Space Telescope, JWST, the most powerful space observatory ever built. This new instrument has already begun to reshape our understanding of the universe, and one of its most remarkable achievements so far has been its ability to reveal previously unseen details about Saturn, the ring giant that has fascinated astronomers and stargazers alike for generations. In fact, these new observations of Saturn are changing the way we think about this iconic planet and about the entire solar system itself. Before the JWST, Saturn had already been studied extensively, but there were still so many unanswered questions. Saturn is one of the largest planets in our solar system, a massive gas giant surrounded by a spectacular system of rings that has long been a subject of intrigue. We had seen Saturn before through the eyes of telescopes like Hubble and even the Cassini spacecraft, which spent over 13 years orbiting the planet and providing invaluable data. But despite these incredible missions, there was always a sense that we had only scratched the surface when it came to understanding the true nature of Saturn, particularly its atmosphere, its rings, and the mysterious processes that govern its behavior. What the JWST has done is open up a whole new dimension of understanding, especially by utilizing its unparalleled ability to observe in infrared light. Unlike visible light, which is what our eyes can see, infrared light has longer wavelengths, allowing it to pass through clouds of gas and dust that would otherwise obscure our view. This ability to peer through the cosmic fog enables the JWST to reveal details that were previously hidden, even from the most powerful telescopes. And in June 2023, the JWST released its first images of Saturn, revealing a side of the planet that had never been seen before. For many, these new images of Saturn appear strangely familiar yet strikingly different. The vast gas giant, with its iconic rings, looks almost like a twin of Saturn in a distant star system. The familiar beige tones of the planet, which we are used to seeing in visible light, are replaced by darker, more mysterious hues. The rings, too, glow in a way we've never seen before, shining in intricate patterns that tell us more about their composition and structure. At first glance, it seems as if we are looking at a completely new planet, but as scientists and astronomers begin to analyze the data, they are realizing that what we are seeing is, in fact, a deeper, more accurate representation of Saturn's true nature. One of the most striking features of the JWST's observations is the way Saturn's northern hemisphere appears in these images. The northern part of the planet, which is just emerging from a 7-year-long summer, appears much darker than we would expect. This was a surprising finding for the scientific community, as previous images of Saturn showed the northern hemisphere to be much brighter. Scientists believe that this darkening effect is caused by the absorption of infrared light by methane in Saturn's atmosphere. Methane, a key component of the planet's atmosphere, absorbs light at certain wavelengths, which results in a deeper, more mysterious look. The darker northern hemisphere may be the result of this methane absorption, which could provide clues about the composition and dynamics of Saturn's atmosphere. But what makes the new JWST images even more exciting is the way they show the rings of Saturn in unprecedented detail. The rings are perhaps the most famous feature of the planet, but until now, our understanding of them was limited. The JWST's infrared imaging technology has revealed details that were once invisible to us. These new images allow astronomers to study the individual particles that make up Saturn's rings, composed primarily of ice, dust, and rock, and to understand the processes that govern their formation and evolution. Some of these particles are thought to be remnants from the early days of the solar system, while others are much younger, constantly being replenished by material from Saturn's moons. The new data provides scientists with an opportunity to learn more about the life cycle of the rings and their relationship with the planet's moons. One moon, in particular, stands out in the study of Saturn's rings, Enceladus. This small moon is known for its active geysers, which spew water vapor and ice particles into space. These icy plumes contribute to the formation of Saturn's E-ring, a faint ring that lies far beyond the planet's main rings. Enceladus plays a crucial role in the dynamics of Saturn's ring system, and the JWST's ability to observe these interactions in such detail is helping scientists understand the complex physical processes that shape Saturn's rings. The gravitational pull of Saturn's moons, combined with their interactions with the ring particles, creates a dynamic system that is constantly evolving. These interactions are crucial for understanding the formation of planetary ring systems and may even shed light on the origins of our own solar system. The JWST's ability to observe in infrared also helps scientists analyze the composition of Saturn's atmosphere in ways that were previously impossible. By isolating specific wavelengths of light using filters, the telescope can measure the chemical composition and temperature of the planet's atmosphere. This is particularly important because, unlike rocky planets like Earth, gas giants like Saturn do not have solid surfaces that can be directly explored. Instead, researchers must rely on data gathered from the planet's atmosphere, rings, and moons to build a picture of what lies beneath. The infrared data from the JWST will provide invaluable insights into the chemical makeup of Saturn's atmosphere, including the presence of methane, ammonia, and other gases that play a role in the planet's weather patterns and internal heat. The question of Saturn's internal structure is one of the most difficult to answer, mainly because the gas giant lacks a solid surface to study. However, by observing the planet in infrared light, the JWST is able to gather data that could help scientists infer more about the composition and behavior of Saturn's interior. The presence of methane in the atmosphere, for example, is a key clue in understanding the planet's overall chemical makeup. Methane is not just a simple gas, it plays a crucial role in the planet's energy balance and atmospheric dynamics. By studying how methane absorbs infrared light at different wavelengths, researchers can make more accurate predictions about Saturn's interior structure, including the possible presence of a solid core. In addition to Saturn, the JWST has also provided new insights into other gas giants in our solar system, including Jupiter, Neptune, and Uranus. Each of these planets has its own unique features, and the new infrared images from the JWST are helping scientists to understand them in greater detail. For example, the new images of Jupiter reveal its atmosphere in striking blue tones, with the Great Red Spot appearing in a completely different light. In these infrared images, the Great Red Spot, which has been a feature of Jupiter's atmosphere for centuries, looks almost white instead of its usual reddish hue. The difference is due to the way the JWST captures infrared light, revealing details about the planet's weather patterns, auroral activity, and storm systems. The cloud bands that encircle Jupiter are more distinct in the infrared, showing differences in altitude and atmospheric pressure. This newfound clarity gives scientists a deeper understanding of the forces at work in Jupiter's atmosphere, and how its extreme weather patterns develop and evolve. Further out in the solar system, the JWST's images of Neptune are equally astonishing. Known as the most distant of the gas giants, Neptune has long been shrouded in mystery, but the new infrared observations have revealed details that were previously impossible to see. One of the most surprising features in the JWST's images of Neptune is the planet's double ring system. In addition to the well-known wide rings, the telescope has revealed a much finer dust ring, located very close to the planet. These fine dust rings had never been visible before, and their discovery is an exciting breakthrough in our understanding of Neptune's ring system. Neptune's atmosphere is also incredibly complex, with extreme winds and storms that drive the planet's weather patterns. In the JWST's infrared images, these storms are visible as bright streaks and patches of methane ice clouds, which reflect sunlight before the methane absorbs the infrared light. These features were previously unseen, but now scientists are able to analyze them in detail and learn more about the planet's dynamic atmosphere. Finally, the JWST's observations of Uranus, the planet that lies sideways in the solar system, have been just as groundbreaking. Known for its pale blue color, Uranus has long been an enigma, but the new images from the telescope have provided unprecedented views of its rings. Uranus has 13 known rings, and the JWST has revealed 11 of them in stunning detail. These rings appear brighter and sharper in the JWST's infrared images, allowing scientists to study their structure and composition more closely. The telescope's sensitivity to faint light has also revealed features in the planet's atmosphere, including storm activity and high-altitude clouds, which were not visible in previous observations. Uranus' extreme tilt, which causes its poles to be exposed to continuous sunlight for years, is also visible in these new images. The planet's unique rotation, combined with its long seasons, creates an environment that is unlike any other in the solar system. The JWST's infrared observations of Uranus offer a deeper understanding of how this strange planet behaves, and the data gathered could provide important clues about the formation and evolution of ice giants. These new discoveries from the James Webb Space Telescope are just the beginning. As the telescope continues to send back data, we can expect even more groundbreaking revelations about Saturn, the gas giants, and the wider universe. Each new image provides a clearer picture of the cosmos and opens up new possibilities for future research. The JWST is not just a tool for astronomers, it is a window into the mysteries of the universe, one that promises to transform our understanding of the cosmos in ways we can only begin to imagine. So, the next time you look up at the night sky and see the distant ringed beauty of Saturn, remember that the images you're seeing are not the same as they once were. The James Webb Space Telescope has revealed a deeper, more intricate view of Saturn than we could have ever imagined, and the journey to uncover its secrets has only just begun. With every new image, we move closer to answering the big questions about the universe and our place within it.